was just gonna say go 7/8 then. I don't know. Okay. I'm gonna kind of skip some of the stuff up there. Well, I don't know. Go to the top, and we're not gonna do exactly what they trying to get us to do, but that's what it has at the top. We did do 7/7.
Yeah, I was gonna say if you kept going, I was gonna.
There is no 7/7.
Yes, there is.
Right?
We did it already. We already did it. I was gonna say once you wrote like the first line.
Yeah.
All right, I know.
Well, this you're doing 7/8 right now.
I was gonna say you totally just wrote 7/8.
I will do it again. And I was like, how does he know?
Do 7/8. I just got lost on what number it was.
I was gonna tell them that you wrote like the first line.
7/8. So this is exponential growth, and let's just write this. So CE to the KT is how they write it. That's exponential growth or decay, depends on the constant. This is your initial value or your initial amount. K is your growth or decay rate. If K is bigger than 1, we're going to grow. If K is less than 1, we're going to shrink. So this lesson is about like a shortcut, really. Like you could do these problems right now without me telling you anything, but there's a much shorter way to do some of them. So see where it says solve dy dt equals ky by using separation. That's what I'm going to do. I'm going to do this right now. So I'm skipping the number 1 and 2 scenario in there. I want to integrate this. I want to separate the variables and integrate this. So I would divide both sides by y, and then multiply both sides by dt. So I'd end up with that. So that's really y to the negative first equals k times dt. So now that I've got the variables separated, and they were already separated up here, I was just rewriting it. I'm going to integrate. So what's the integral of y to the negative 1? Essentially, you guys are going to get mad about the absolute value again. What's the integral of k? No, k is not a variable. K is a constant. It's a number. That's the derivative. Kx. Kt, sorry. Yeah, because we are with respect to t. My bad. Then we're going to go to e. We're going to exponentiate both sides. And so over here, this becomes e to the kt plus c. I'm just going to I'm trying to explain the absolute value thing again. Forget the left hand side. Agree there?
Yes.
Then do you agree with that? Because that, I'm just telling you, I'm just separating, right? If you're multiplying the variables, you'd add the powers, and I just wrote the same thing, just like a different way. Would you then agree that I could write it like this? Because e to the c is a constant, and I'm just saying it's a constant. Now, would you agree that the c could be positive or negative? Which means I don't need the plus or minus signs anymore. So when I had like a specific solution, like f of 0 equals 3 or whatever, then I need to know if it's positive or negative. But the positive or negative here is like inside of the c, and we just don't know it yet. So like, is this correct? Sure. But is there any reason to write that c? I'm sorry, is there any reason to write the plus or minus? There is a reason to write the c. There's not a reason to write the plus or minus. So two things. I wanted to clarify that ln situation. And also I want you to realize that if you see this, it is exponential growth, and the k goes in front of the t, and then you just have a constant in front. So you could work all that out, or you just gotta, I know I'm going from there to there. And this isn't like some crazy cheat shortcut that I'm trying to like show you something to get around things. This is like what the lesson is that shortcut. So let's look at like number 3. So dy over dt equals 6y, so that's really dy over dt equals ky, where k is 6. You don't have to, you're not going to end up writing that. Like, I'm just trying to do it to explain it. But I can look at that and say, okay, well that means y is going to be some constant times e to the kt power. Or I could go through all the steps and separate the variables and unpack it and integrate it and do it, but to me this is a lot easier. We're not done though, we got some other pieces here. C represents your initial amount, whatever you start with. So what is C going to be in this problem? It's going to be 5, because they're telling us y is 5 when t equals 0. What is k? 6. That's your answer. Like, you're literally done. Starting amount, because they gave us the 0.0, 5, so that is the starting amount. Oh wait, sorry, 6. That's 6. That's y equals 5e to the 16. That's your answer. Sometimes you gotta do something with it, which we'll do in a second. Like we might have to find a k in some situations, but for that one we're done. We're looking for dy over dx equals negative 3y. And they're giving me the 0.0, 4. So they're basically giving me the initial value. So I'm going to use my shortcut to jump from this to, okay, I know that's got to be y equals a constant times e to the kt power. What's my constant? Like, what's the starting amount? Oh. What's k? -3. So, like, those are just write it, and you're kind of good. They're not all like that, but that's the shortcut that they're trying to teach you. If you see this, you can jump to this. But they do get a little, this is still not necessarily, I don't even know if I would call this count. But let's look at the next one. It's really more of like an advanced algebra. Kind of. So, I got some numbers in there, but the sentence I see that matters the most is that the weight of the animal is increasing. So that's dw dt at a rate proportional to its rate. So remember the direct proportional and the inverse proportional? It says proportional, that's k times something. If it says inversely proportional, it's k divided by something. So this is going to be k times, and what is it proportional to? Well, it's proportional to its weight. And that's the exact same setup as like we've been doing dy over dx equals ky. We're just using w instead of y. And no one even told you you had to use w. So if you want to use y, go ahead and use y. So that I can jump and say, okay, I know y equals c e to the kt. Sorry, w equals c e to the kt. And they're asking me a different question here. So that's the equation I need to use. This is the differential equation that I just shortcutted to here. And I gotta answer a question, so they give me 3 pounds at birth. So when 0 time has passed, they weigh 3 pounds. And then when 3 months have passed, it weighs 4 pounds. Question is, when 5 months has passed, what is the weight going to be? So it's really just like a system of equations, basically. We're going to plug in 0 and 3 here. So 3 is the weight. Times e to the, so k we don't know. And time is 0. pounds at birth, so what's C gonna be? 3. Well, I just proved it if you want to like, question that. Sorry, so we get to here. And then I'm gonna start using these. Like I didn't really need that. That's just telling me the initial amount. I don't really need that. Beyond that. So then let's plug in 3 and 4. So 4 equals 3 times E to the K times 3 power. My objective here is to solve for K. Are gonna need your calculator. I can divide both sides by 3. So 4/3 equals like E to the 3K. But I've got an issue where my variable is like upstairs in the exponent. Remember how to get that down? ln both sides. So then I get the ln of 4/3, the ln and the E go away, and that equals 3K. And then divide by 3. And go to your calculator and let's see what that is. So I get, I'm gonna write things down, but I'm really gonna try to leave the value in the calculator. We can round to 3 decimal places, but that's at the end. When you're working your way to it, you try not to round. We agree on K? Good. Okay. So then I can go back to this guy and rewrite it. I'm smarter now. Y equals 3e to the 0.09589 times t. And now I can answer the question because they said how heavy at 5 months, so my job is to plug 5 into t. So in your calculator, I'm not going to round, I'm just going to use like the previous answer thing. So I'm going to type 3 times e to the power of second. I'm using the 84 calculator, yours is different. I think it's second header on yours that's to equal. You guys gotta help me out. I don't have an 89 with batteries. What I'm trying to do is do like the previous answer times 5. How do you do that on the 89s? Second minus? That's the same thing as a minus. Okay. So it's second, and this way it's not ever rounded. It's using that entire legitimate full answer, and we get a more accurate value at the end as a result. So there's your answer, 4.845. That's what this is. But like, we wrote down a calculus equation up there, but then I think you guys did this in like honors and math algebra. You just plug in, find the constant, and then plug in again. One more, so let's do 6. Mr. Krabs. So they give me that, and they're asking about doubling time. Doubles every 7 years. We're supposed to find the value of K. So there's the calculus, but I'm going to put it in the advanced algebra pretty quickly. So C e to the K times T. And it doubles every 7 years. So think about what would happen. Because a lot of people are like, well, how do I know what I start with? Great, it doubles the one I start with. It doesn't matter. So there's going to be a 7 here. That's like 7 years. Let's say I started with 50 grams, whatever. If it doubles, what would go here? 100. What step is to divide, and what would I get? 2. So it doesn't really, you can pick like 2 there. When it doubles, it'd be 4. Your first step is gonna be to divide. So it doesn't really matter what you pick. You could even do like, I don't know what. So you could make up numbers and say like 100 equals 50 times e to the kt, and then like divide it. Or you could just jump to this and be like, well, I know it's supposed to double. And really, this is still representing doubling also. It's just saying like we started with 1, and we're gonna double. And then t is 7. So it's like 2 equals e to the 7k. And then we gotta solve that. So how do I get the variable down? Natural log. So natural log of 2 equals 7k. And then if I want k by itself, I just divide by 7. But you can leave it. If it's multiple choice decimal, you don't match it up. But either way there. Question on any of the notes? Part? Okay, go ahead and get to work. Yeah, I'm looking. Uh, 13, yeah. 14, it's okay if we're gonna do 14. But 13 on the test prep was a good one. We're done with the